Hey guys, this is Professor Janacek. I want to go over an example where we find surface area. So let's find the area of the surface generated by revolving the natural log of x plus square root of x squared minus 1 over 2 between 5/4 and 17/8 natural log of 2 about the y-axis. Whew, this is going to be fun. All right, well, I've already graphed it, and just so you know, all I really did is first I verified that these 2 points really are in this function. Right, if I put those x values in, do I really get those y values? And then I took those two points and I simply plotted them. There's one, there's the other. I also know what the natural log function looks like, regardless of its argument, always has that same shape. So I drew that natural log shape, and then I just revolve that about the y-axis, and that's really all I did. So take your time, make sure you know how to get this graph. Okay, so we're dealing with y equal to the natural log of x plus the square root of x squared minus 1 over 2. We have a function y in terms of x. So it looks like we're going to use this first formula. And don't forget where that comes from, right? We talked about that in the previous video. But looking at that, I recognize that I'm going to have to find f prime squared, which means I'm going to have to take the derivative of this and then square it. Now, I can take the derivative of a natural log function, but there can be problems with that. So it might be useful to change it to a function of y and use the second one. So let's try that and see if that makes it a little easier to work with. So I want to solve this equation for x. So in order to get x by itself, I need to get rid of the natural log. So I'll undo that using the inverse function e. Which gives us e to the y is equal to our original argument. Okay, clear the fraction, that's easy enough. Now I need to get x by itself. Well, in order to do that, I need to get x out of the radical. So let's isolate that radical. And then clear it. Okay, on the left-hand side, I need to square that. Now, if you need, take your time. Remember that's 2e to the y minus x times 2e to the y minus x. And then multiply all that out. And combine like terms. So make sure, take your time and do that. Now I've done a lot of these, so I know what we'll get. We should end up with 4e to the 2y minus 4x e to the y plus x squared. That's on the left-hand side. On the right-hand side, that radical goes away. We get x squared minus 1. Now if I subtract x squared from each side, it ends up going away, which is kind of nice because then I just have an x in one spot. So now we need to simply isolate that x. First thing I want to do is let me go ahead and add 1 to each side and add that 4x e to the y to each side. I really just did that so I don't have to worry about those negatives, losing out on those. All right, let's see. So to get x by itself, there are a few ways of going about this, so whatever works best for you. I do want to go ahead and simplify this a bit, so let me separate these. And we end up with x is equal to e to the y plus 1/4 e to the negative y. All right, and I think taking the derivative of an e function is much better than taking the derivative of a natural log function. So let's go with this. All right, so here is our function. Instead of calling it x, though, I'll call it g of y to keep in line with the formula we have written at the top of the page. All right, so looking at that formula, I realize I'm going to have to find g prime squared. So let's go ahead and do that. G prime e to the y. The derivative of that is simply e to the y. The derivative of 1/4 e to the negative y, there is a slight substitution in there. You end up with negative 1/4 e to the negative y. Make sure you understand why it is. Don't just memorize this. Make sure you understand where that comes from. It is a simple u substitution. Make sure you recognize how that substitution works. Then, of course, we need to square this. Again, if you need, write this twice. This is e to the y minus 1/4 e to the negative y times e to the y minus 1/4 e to the negative y, and then multiply a bunch of stuff, combine like terms. Make sure you know how to do that. Take your time with this. And let's see, again, I've done a few of these. You should get e to the 2y minus 1/2 plus 1/16 e to the negative 2y. All right, and there is g prime of y squared. Now, make sure you can do all of this, all of these things that we've just done, going from y, a function of y in terms of x, to a function of x in terms of y, also finding g prime and finding g prime squared. Make sure you can do all of that without looking at what I've just done, right? Take a moment, get out a blank piece of paper. Can you work this by yourself? It's one thing to be able to look at my work and say, oh yeah, that makes sense. I see what's going on. But it's a completely different thing for you to work it yourself. So please, please take some time and practice doing that on your own. Okay, now comes what could be the easy part, but we'll see. We're going to use our formula. S is equal to the integral from c to d of 2 pi g of y square root of 1 plus g prime of y squared dy. Again, probably a good idea to remember where this comes from. Why is it 2 pi g of y? Well, that's from 2 pi r. Make sure you remember that our surface area comes from the length times width. The length is the circumference. The width is the length of the curve. So don't forget about all that stuff. Okay, moving on. We are integrating. Now, these need to be y values that we're integrating across. So looking at the y values, notice my y values go from 0 to the natural log of 2. Don't get mixed up. Don't use your x values here. So we're going from 0 to the natural log of 2 of 2 pi times g, which is e to the y plus 1/4 e to the negative y, times the square root of 1 plus g prime squared, or e to the 2y minus 1/2 plus 1/16 e to the negative 2y, and dy. All right, let's see. This isn't looking great, but I think it's going to actually end up being not too bad. First thing I want to do is let's go ahead and factor out this 2 pi just to make it a little easier. Now, inside the radical, I notice I can combine the 1 and the 1/2. So that gives me e to the 2y plus 1/2 plus 1/16 e to the negative 2y. Now, I recognize this e to the 2y plus 1/2 plus 1/16 e to the negative 2y. That looks a lot like this right here. The only difference is that we have a subtraction rather than, we have an addition instead of a subtraction. I also see where that one came from. It came from this. So that means we can write this here inside the radical, we can write this as e to the y plus 1/4 e to the negative y, parentheses squared. And all I'm doing is kind of going backwards from that statement right there. Right, using the same idea, it's now just a summation, a sum rather than a difference. Okay, well that's nice because inside the radical I have something squared. Square root of something squared, very easy to work with. The square root and the square both go away. Oh, isn't that nice? All right, well now we just need to multiply those things in the integrand. Again, if you need, take a moment, multiply, 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 combine like terms. See what you get. It should be e to the 2y plus 1/2 plus 1/16 e to the negative 2y. Again, take your time with that multiplication. And now I think we're ready to integrate. The integral of e to the 2y, there is a u substitution in here. You should end up with 1/2 e to the 2y. Integral of 1/2, remember we're integrating with respect to y, so that's 1/2 y, plus 1/16 times the integral of e to the negative 2y. Again, a little u substitution, take your time with that. You should end up with 1/2 e to the negative 2y. We're going to evaluate that from 0 to the natural log of 2. Again, take your time with that integration. There's lots of little u substitutions, and it's probably a good idea to understand how those substitutions work. Don't just memorize these little integrals. All right, but I think that was the difficult part, and now it's simply a matter of evaluating it from 0 to the natural log of 2. I'm going to let you go ahead and take a moment to do that. You should end up with pi times 195 over 64 plus the natural log of 2. Well, how about that answer? Enjoy!